So hi everyone, this is the demo of my news rack chatbot project, which I'm going to show you in a minute. So here it is, which we have named as Smart News. So this application that I have built allows user to ask question about the recent news articles and receive the information using the RAG architecture, that is retrieval augmented generation. Uh, Before coming to the technical functionalities and details of this particular application, I will show you the demo first, and then we will deep dive into what tech stack we have used, what architecture we have used, and what are the future improvements that we can do. So let's get started. So on the screen, first I'll try to write in the chat window hi to see what it generates. So here you can see that it has generated the response, and it was a typed out response. We have done this particular functionality in the front end of React.js. After collecting all the data, we are providing information in the typed out format. Coming to the next. Now let's try to ask it some real world question about the news. How is the global market? So this was the response it has generated. So now you can see that it was also a typed out response. So now one more thing, let me ask just to check the prompting that we have done for the system. Can, by asking some different question, like different domain question, can you generate a Python code for me? Let's see. Okay, so it was able to give us this response that it's a news assistant and can't generate Python code. Now let's check one more thing about the reset functionality, which was being mentioned. So let's check that as well. First, let's try to refresh this. Let's see how it persists, like whether it persists or not. So it's taking some amount of time. Now you can see that the response is persistent. Okay, now let's try to reset this response. But before that, I think we should check that why it's persisting. Because if I'll go into the application, into the local storage, we have stored the rack session ID. This ID is being stored into Redis, and we have applied TTL over there. That is time to live, and we will get back to that as well once I'll start explaining the functionality. So now let's try to reset this. So now you can see, even if I'll refresh, you wouldn't be able to see the earlier chats, and now it has also deleted into the Redis as well. So that was about the demo. Now let's see its functionality. So before starting with the functionality, let's start with the tech stack used. So for the front end, we have used React, JavaScript, that is the ECMAScript version 6. So now let's see the tech stack that we have used for this project. So in the front end, we have used React, JavaScript, CSS, Sass, Lovable, and Vite. React is for developing the front end application. It's a library which we have used. JavaScript is a language which we have used to write the code. Then CSS, and so then we have CSS and Sass, Sassy CSS. So it's basically the superset of CSS, which eventually turns into CSS, but it provides us some additional functionality. So we have used that. After that, we have Lovable and Vite. So Lovable is the AI LLM website generator, which we have used to generate the front end of this project. And then we have Vite as a development tooling. So we were able to make some changes into the application after generating it from the Lovable. We added some APIs and some functionalities like typed out response were being implemented by me. And coming to the backend of this application, we have Node.js as a runtime. Then we have used TypeScript as a language, which eventually turns into JavaScript, and we have used the TS Node div for doing that. Then we have Express.js as the backend framework for writing the REST APIs, and we have followed the REST API practices, as you can see. Then for the AI and LLM, we have used Google Gemini text embedding 004 model for generating the embeddings of the responses of the text. And then the Gemini model for AI answer generation we have used is Gemini 2.5 Flash. The vector database that we have used is the Quadrant Cloud. And at the end, we have this caching and session management. For this, we have used Redis, which is for which we have used Upstash platform to get the Redis And for data ingestion, we have used RSS feeds, and we have also some news sources. For the deployment and infrastructure, we have used like Render for a backend deployment and Netlify for the front end one, as both of them were free, so we were able to deploy them over there. And version controlling and tooling here for the backend, what we did was like Git and GitHub for both the front end backend project to to maintain the version control of the complete project. Then we have used npm, that is the node package manager, which we have used for managing the modules packages that we had. Then we have ts node dev. This is a development dependency which we have used to compile the TypeScript code. So this was about the tech stack. So now let's see the workflow of this complete application. So let's start with the front end. Once you hit the enter after writing some chat, it goes to the backend and it just gets to the route/chat, and then it triggers the handle chat service. So in the handle chat service, we pass the session ID and user message. And then what does this handle chat service does is that it stores the user response into the Redis, and we have provided the TTL is 30 minutes. The time to live, that it stands for time to live. So here every message resets it to 30 minutes because every message consists of that TTL is 30 minutes. For 30 minutes, if we don't receive any response, the session ID and the messages gets deleted because Redis automatically deletes that particular key, which is like we have called as session, which we have called as session ID. Coming to the next, once we store that, then what we do is we provide this handle chat to the context retrieving service by providing the user message. So first the user message get embedded using the Gemini embedding model, and whatever embedded response, whatever embedded query that we have got, we pass it down for semantic search in the quadrant DB. And once we do that, we get the complete context and of this particular query from the rack, like as this quadrant DB is storing all the articles. So we do semantic search using our query. So we get the complete context. Now with the context and the user message, we pass that down to the Gemini AI model, which then provides the response to the handle chat service, and also stores that response into the Redis, and then handle chat service provide that response to the front end. Let's check the next one, that is the history one. So history is very simple. We need to pass the session ID, and it goes to Redis and get the history of the particular session ID which we have. If it hasn't exceeded 30 minutes, you'll be able to get the history. Otherwise, you'll get the blank response. And that session ID will be considered as a new key with the new session being started. Reset session is like we can reset the complete session, like we can reset the complete, like delete all the data for that particular session ID into the Redis. So that was about the reset session ID. So this was the smart news RAG chatbot complete workflow. Now let's see the RAG pipeline that we have done. So we have implemented this as an offline script where what first we do is we first collect the news from various news sources and RSS feed, and then we clean the text like the HTML tags, the scripting tags, whatever that will be there. Then we form the chunks, and then we stream that chunks, like we pass that chunks to the embedding generation service, which connects with the Gemini embedding model and generates all the embeddings, and all the stored embeddings are then passed to the quadrant DB to get stored. So this is how we have stored for the quadrant DB. So this is how the RAG pipeline works. Now let's see the future improvements that we can implement. So the first one is to introduce WebSocket based communication for real-time response and token streaming. So now as earlier I've explained into the demo, that we have typed out response, not the streaming response. So to get the streaming response, what we need to do is we need to get a WebSocket architecture, which will help us to have a real-time communication and get the token streaming. Because what it will does is whenever the Gemini will generate a word or two, it will be then automatically passed to the front end. So then we won't be needing a typed out response. Then we have scheduled automated ingestion jobs to keep news data up to date. So here now you've seen that the RAG pipeline that we have created, so it's been running offline, like we run this script manually. So what future improvement here we can do is we can automate this complete process. So every time we will have some new articles into the quadrant DB, and as for that we will get the response using load balancer and Redis. So here you can see the architecture that we have. So once the browser hits this our URL of the once the browser hits the URL of our application, it goes to the load balancer. It could be Nginx or maybe AWS load balancer, and then it goes to and as per the decide which WebSocket server it goes as per the scheduling algorithm, maybe round robin algorithm, and then it will go to some WebSocket server. As I told you that we'll be using WebSocket for streaming. And this will be a stateless backend. All three of them, the states, like all the data will be stored into the Redis, and from here itself it will get the data. Why we have, and then we have this WebSocket server, all the ingestion, like all the news articles it will take from here. That is the Quadrant DB. So here you can see the scalable architecture, and that is what we are going to implement. So thank you for persisting with me till this part of video, and have a great day ahead. Thank you.